Okay, so this is a lesson on the intersection of three planes. Okay, so you have a number of situations here for there to be an intersection point, or at least one point. And the first one is if all three planes intersect at one point. Okay, so if you had three random planes that you put out there, there's a good chance that they would intersect at one point. That's the most common situation. So imagine if you had two walls and a ceiling. Okay, so for example, in this room, we've got a wall going up one side along here, and then another wall over there, and then the ceiling up there, and they all intersect at that point. So that's pretty convenient. They're all at 90 degrees. Okay, so right at the corner they intersect. And then another situation would be as if the planes all intersect at a line. Okay, so you can imagine here's a plane. There's two planes, these pieces of paper. Okay, so they intersect at a line. Now you take another piece of paper and put it in there like that. Okay, so like on another angle, and then you'd have three planes that intersect at a line. So I'm hoping you can see that. So two planes at another one in there, in between those, and they all intersect at that line. Okay, and for that one, you've noticed that the normals are all going to be coplanar. So the normals on that one would be coplanar. So for example, let me just draw this out here. Okay, so if you had this is a normal, and this is a normal, and this is a normal. Well, the three planes would come out of the page like this. That would be, have that as the normal. Like that, with this one as the normal. And then like this, with this as the normal. Okay? And so we know that if the three planes intersect at a line, then the normals are going to be coplanar. Okay? Now, two of the planes could be coincident, right? So if two of the planes are coincident, then you also have the normals are coplanar. Okay? If two of the planes are coincident, then either two of them are the same, and you basically have the situation where you're intersecting two planes. Okay? Or you have three planes that are coincident, and then the intersection is just a plane. It's the first two that we're really interested in. Okay? So here's an example. So randomly choosing three planes, and the numbers happen to work out very nicely in this one, but I randomly chose these planes. So here's the three. You want to intersect them, so you're going to use elimination to try and get rid of a variable and get more equations, two more equations that are just down to two variables, two unknowns. So there's a number of ways of doing this. So I chose to eliminate the x in 1 and 2, and then eliminate the x in 2 and 3. Okay, so eliminating in 1 and 2, we're going to get this. So 2 times equation 1 minus equation 2, and we're going to do the subtraction here. Remember to multiply the other side of equation 1 by 2 as well. Do the subtraction, the x's go away, and we get this equation here. We're going to call this equation 4. Okay, and we're going to come back and need that. Now I'm going to eliminate the x in 2 and 3. I could have used 1 and 3. In fact, it looks like it might have been easier. And you can try that and see if you get the same answer in the end. It would have been fine to use 1 and 3, but I chose 2 and 3. Okay, so in 2 and 3, I'm going to eliminate the x by multiplying equation 3 by 2 and subtracting. Now I've got another equation with just y and z in it, and I'm going to call that equation 5. So now I have equation 4 and 5, two equations, two unknowns of y and z. Now I can just use what we did in grade 10 to find the y or z. Okay? So I'm going to now use 4 and 5 to eliminate y. So I'm going to have to multiply 4 by 5 and 5 by 3 and then subtract them. When I do that, again, don't forget to multiply the right side by the numbers. Those are the two equations that you get. Subtract them, you get 46z equals 0, which means z equals 0. Well, that's convenient. Now that we've got z, we can sub that back into 4 or 5. I'm choosing 4 to sub it into. And we get y equal to -1. Okay? Sub 0 and y equal -1 into 1, and we get x equal to 1. Now we've got the intersection point of x equals 1, y equals -1, and z equals 0. Okay, so we're going to call that the point of intersection. Alright, so now we're going to do the same two first lines, but I'm going to pick a third line so that we get a line of intersection. Well, if we want a line of intersection, remember that the planes, the normals, must be collinear. So all I'm doing here is I'm going to take the normal for one and subtract the other. That's a linear combination which gets another normal in that plane. Any linear combination of these two normals gets me another normal in that plane. So if I do that, I go to -1, which is 1, 1 minus -1, which is 2, and -3 minus 1, which is -4. So this will give me a plane where these three planes will give me a line of intersection. Sorry, I had that out of the camera there. Okay, so I subtracted the normal from the first one from the second one to get this normal. And then I just chose a random constant at the end here. Okay. Now I'm going to eliminate y in 1 and 2. So add 1 to 2. It'll eliminate the y. I got 3x minus 2z equals 3. Again, call that equation 4. Now I'm going to eliminate y in equation 2 and 3. 2 and 3. Well, I'm going to multiply equation 2 by 2 and subtract them. So 2 times equation 2. Subtract them. I get 3x minus 2z equals 3. Well, what's interesting here is I get 2 of the same equation. So 4 and 5 is the same equation. So if I try to eliminate now with 4 and 5, well, what happens, you do equation 4 minus 5, you get 0 equals 0. So really we're down to either equation 4 or 5, same thing, and one of the other equations. Okay, so I'm going to use equation 1 and 4. And there we are, we have them written out. In this, I have two equations with three unknowns. We know how to solve this. We're going to let one of them equal a parameter, t, say. We know we're getting a line of intersection, so this is possible. Okay, so let z equal to t, and then solve. So if you let z equal to t, the first equation becomes x minus y equals 2 minus t by bringing that over. And the second one becomes 3x equals 3 plus 2t by bringing the negative 2t over. Okay, well that makes it easy to solve for x. We've got x equals 1 plus 2/3 t by dividing by 3. Now we substitute that into 1 to get y, substituting that expression in for x in number 1. Now we can solve for y. And y equals -1 plus 5/3 t. And these are the parametric equations for the LOI, the line of intersection. Okay, and that's it for that one.